This is the dot. The dot can be scalar, which is just a number with no direction, or a vector, which is a normal vector, U and V. U can be used to find a magnitude, which could equal the distance formula. The distance formula is 2 plus y. 2 equals y half. So for it to be scalar, it would have to be vector vector. And for it to be a vector, it would have to be vector vector vector. So 2 and 3. And you need properties to figure it out, which are, number 1, U times V equals V times U. Number 2 is times V equals that. Number 3 is U times parentheses V plus W equals U times V plus U times W. Number 4 is V times V equals magnitude V squared. And number 5 is C U times V equals C times U times V equals U times C V. An example of the dot product. An example of the dot product is we can have our U, our V, and our W. Our U is -1, 3. Our V is 2, -4. And our W is 1, -2. So to find UV, we have to multiply U times V, which will be -1 times 2 plus 3 times 4, which equals -2 minus 12, which equals -14, which gives us our U times V, -14. You have to find our W, which will be obviously 1, negative 2. But that can't be the answer, so we have to put the 14 here and use our other property, u times 2v. So 2 times uv, which will equal 2 times negative 14, which equals negative 28. And that gives us the next number. And we have our dot property right here. Right here. Will be the problem u equals 4i minus 2j. And v equals I minus j. So we're using the numbers instead of the j's. So obviously this would be a 1 and a 1. 1, negative 1. So we need to use the numbers in the front of the letters. So u would equal 4, negative 2, and v would equal 1, negative 1. There's an explanation to understand the i's and the j's in the problem. To find the magnitude of u, you would have to, which is basically the u with the double lines, you would have to put u times u equals 5. So the square root of 5 equals w. To find double W, W is actually 1, negative 2, and W times W equals the double W square. So that gives us square root of 5 times negative 1, which brings us to having to put 1, negative 2, 1, negative 2, which is this. Equals double W squared. We're still finding the W now, not the U anymore. And then we do 1 times 1, negative 2 times 2 using the dot property equals W squared. So then that equals 1 plus 4 equals 5. And the square root of 5 equals the square root of this W squared. These cancel out, so we're just left with square root of 5 for W. In order to find theta in the dot product, you have to use an important equation, which is cosine theta equals u times v divided by w times double v. An example for finding theta in a vector would be having your u and your v, u being 4, 3, and v being 3, 5. So what is theta? First we have to do the dot product between v and u. So 4 times 3 plus 3 times 5. 4 times 3 equals 12 plus 15 times 5, which 12 plus 15 is 27. This is where we use our cosine formula and plug everything in. So cosine theta equals u times v divided by w times double v. So cosine theta, have our 27 there. But then we have to find our w. To find w, we have to do u times u. Let's square this. We have to put 4 times 4, which equals 3 times 3, which comes from our 4 and 3 here. So 3 times 3 equals 9, and our 4 times 4 equals 16. So then those two added up equals 25, which equals w squared. Now squaring that equals 5 equals regular w. So that's where we get our 5. Now we have to find our double v using our vector for 3 and 5. So double v squared equals v times v. 5 times 5, 9 plus 25 equals 34, which equals double v squared. And then you square that. Double v just stays as square root of 34 since it doesn't go lower. And we put that up here. Square root of 34. After that, we have to put cosine theta equals, when you put this in a calculator, you get 0.92609. So the answer is 92609. And putting your calculator in degrees, you get 22 degrees. And that is the answer.